Many of you in the audience today are here because you lead very active lifestyles. Whether this lifestyle consists of recreational activities, sports at the athletic club, or workouts at the gym. As avid participants in these activities, it's important for you to understand exactly what your body is doing while you're performing these functions. Whether it's jumping up and down, running on a treadmill, or throwing a ball, your body is in constant motion and working through processes that enable these movements. So today, we're going to break it down to the basic foundation of muscle contraction. We'll go through the contraction process, the relaxation process, and a couple questions at the end of the speech. So to start with, we're going to go over the anatomy of a nerve. Okay, we're going to start with the cell body up here and the dendrites, which branch off of the cell body. The cell body is then attached to the nerve trunk, which is surrounded by a myelin sheath. This then goes down and branches off to the terminal branches, and at the end of those terminal branches are the motor end plates. The motor end plates then attach to the muscle tissue, and we'll get to that later in the process. So we'll start off with the muscle in a resting state. This is where no activity is going on, it's relaxed, and there's no contraction whatsoever. The motor nerve potential arrives down the nerve trunk and down here to the motor end. When it reaches the motor end, acetylcholine is released down here at the nerve junction. Once the acetylcholine is released, calcium is released from the sarcoplasmic reticulum to the T-tubules. When calcium is released, it bonds to troponin down here. Now, troponin acts as a blocker. As a blocker, it means that it will not allow the muscle to contract because it stops the actin molecule up here. So once calcium is released from the sarcoplasmic reticulum, it eliminates this troponin, which allows the tropomyosin and actin to come closer together. As this is also known as a cross-bridge formation. So as a cross-bridge formation completes, these two come closer together, and these Z-discs come closer together as well, which completes the contraction completely. Now, once the contraction is complete and it goes into the relaxation state, cholinesterase is released and the acetylcholine is broken down. The sarcoplasmic reticulum, as we saw up here, then brings together all the extra calcium that was released during the initial contraction. It brings it back to the sarcoplasmic reticulum, which then puts the troponin blocker back in place. Once the calcium is reabsorbed, the cross-bridge formation is terminated and the contraction ceases, so the muscle goes back to a relaxed state. This can occur as many times as needed. Whether it's flexing your arm or flexing your leg, those contractions happen, and this process has to be completed every single time. Another form of contraction, also known as fasciculation, are also known as spasm and twitches. Now these are not, they're uncontrolled and they're involuntary, much different from a regular muscle contraction as bending your arm. Those are controlled movements, and the signals are sent from your nervous system to initiate those movements. An uncontrollable twitch is unexpected, it's involuntary. These can range from very minor twitches, seen most commonly in the hands, in the facial features, in the calves. They can occur anywhere from minor twitches to severe spasms. Now, severe spasms can be very, very painful, and they can last. They're usually eliminated with use of massaging, stretching, even some painkillers known as muscle relaxers. Release a chemical compound in there to stop the contraction and relax it. So, some causes that might spark spasms or twitches, one could be diet deficiency. You may have too much caffeine in your system, which can cause your muscles to just overreact. Dehydration, electrolyte imbalance, and a magnesium deficiency. Exercise also plays a huge part in muscle spasm. As physically active people, you know that when you work a muscle enough, it becomes fatigued. Once that muscle reaches fatigue, they may begin to spasm, and this is where they can get kind of painful. Charley horses, major cramps, they all play into a part of muscle contraction, where that muscle contracts and it does not have that calcium to release that contraction. Anxiety and stress also play a huge part. You may see minor tics in people who are under a lot of stress consistently throughout a long period of time, and those who don't sleep. If you don't get enough sleep, your muscles have no time to relax at all. On a more severe state of twitches and spasms, they are also associated with long-term diseases. Such diseases consist of Kennedy disease, Lyme disease, and Lou Gehrig's. Now, naturally, most spasms and twitches are benign, and most people don't think much of it, but there also is a mental factor, which is the more you think about a spasm and how concerned you get about it, that will affect the frequency of it and the consistency of it. So most of it's a mental thing. This is a process that occurs every day. Every time you move, every time you twitch, every time you fidget, this process has to occur and several times. It's very quick, it's very repetitive, and it's necessary to body movement. Any questions or comments?
How does alcohol affect your muscles?
Alcohol does not necessarily inhibit muscle movement, but it can inhibit the severity of it. So your muscle may not contract as much or last for as long. Normally you hear of people in car accidents who are very maybe intoxicated. They survive horrendous injuries they survive horrendous crashes without any injuries. And most of that is because your body is not tensed up during the accident and your muscles are more relaxed and loose, so to speak. So that sort of tension doesn't, with that lack of tension there, it doesn't cause the severe injuries that a tense person would undergo in such a situation.
You say diet can affect these twitches. If you change your diet, do these twitches go away, or is it a permanent thing with the food that you eat?
Naturally, if you drink a lot of caffeine and that causes a twitch or it causes a spasm of some sort, if you were to drink water or Gatorade, that would definitely probably reduce the amount of spasms or twitches you had. They may not eliminate entirely, but I would assume that over time it would probably eliminate the spasm if you made changes to your diet that were strongly affecting it. Any other questions, comments? All right, thank you guys for coming.